So, how was the keynote? Good? Enjoyed? Good. Okay, so we're top of the hour. Let's start. So first of all, welcome everybody to this session. We're going to talk about IoT, Internet of Things, and machine-to-machine communication, and how is changing our world. And my first question is, do you think it's changing? Is it changing anything to start with? Or yes or no? Are we feeling it every day?
We hear it every day.
Oh, okay, we're hearing it every day. Let's try to see if we actually are feeling it every day, because sometimes there are that disconnect, because sometimes things are there, but it's invisible, but it's actually already helping us. So my name is Nuno Godinho. I'm originally from Portugal, now in UK. So as a disclaimer, this is only my opinions and not my company ones, just for everybody to know. And I'm a general manager for software engineering, software CTO for Europe in GE Healthcare. You probably heard about it. So we do a lot of things. And yeah, Internet of Things is one of them. Cloud, leveraging cloud is another one, but with only one reason and one goal, which is trying to get better the smart health. Everybody talks about smart watches, smart houses, smart phones, smart things. I would love to have smart health, because really that's not the feeling I get when I need anything from health. And so I decided it was time to do something about it. And now I have the challenge. Now I need to handle and try to do something different. And so I'm also Windows Azure MVP for long years. I've been an MVP for 8 years now. Last 5 has been since the actual program started in Azure. And also N-Service Bus Champ. How many of you know Azure? Have played around with it? N-Service Bus. Anybody? Okay. So, to start and to explain a little bit, and one of the things is, okay, why healthcare, IoT, what do you do in your day-to-day basis? So I decided to bring a couple of images which I like to use and actually help me when I was deciding, do I take this role or not? And so one of the things, how many of you can tell me what this is?
Lungs.
What?
Lungs.
No?
Lungs.
It's an embryo. 2 ones. It's twins, actually. So this is one of the things we do. How can IoT help us here in doing this? So we started doing this type of imagery and things like that. We have all the machines, equipments doing this. But how is that? Is that IoT or machine to machine? What do you think when we start leveraging? This is communicating with devices and then receiving in other machines and then receiving commands. Is this IoT or machine to machine? Thoughts?
Depends what you're doing, really.
It depends what I'm doing. So it's most of all is machine to machine communication. Have one machine communicating with other machine and providing status and providing command and control. Then I actually have, in terms of IoT, is when we go to the next level and you have all of the machines where we don't have, in this case, we have a restriction around the hospital. I really don't want to get sued, so the hospital is where the boundaries are. So we are in the machine-to-machine communication. So machine-to-machine is when we have this communication, but we define the boundaries. Is within a car, is within a hospital, is within a set of boundaries. Okay? It's the same thing, but within a boundary. The Internet of Things is when we go beyond this. Is when we open that to the whole wild world, and then we basically have In this, which is we're using the equipments are feeding information, status information, which are fed for the hospital, and then there can be done a lot, and there is being done a lot of analytics based on this. Another example is this. How many of you have seen one of these? For me, that's a very cute one. Because how many parents, I remember in 2007, 2008, when my wife was pregnant, I was in Portugal. We still didn't have this ones, and we found a way to get one of these because it's cute, it's nice, everything. Also, what's interesting is a lot of this information. So what you see here, which is a picture and an echo being done, it's basically no more than thousands and thousands and millions of data points that you're receiving. It's DICOM that you're talking. And this is what generates this image. Now imagine that we can actually use this every single data point in order to track and understand if there's any abnormality whatsoever and track that. And then actually immediately send a notification to yet another machine in order to start preparing for some kind of system. I have a friend of mine where unfortunately her baby had to get born and immediately got to surgery because there was a heart issue. So this machines with machine-to-machine communication, this actually, while tracking this, immediately can send the information to the other machines, to the OR and everything, say, this is what needs to be done. And again, we're talking machine to machine. Why? Because we are within a boundary. Does that make sense? Another thing, and this is a little bit apart from a cell, how many of you can tell me what this is? If you can, I'll definitely need to figure something out to give you.
Is that flower? See,
Which?
that one.
It's a what?
Like a dandelion flower.
No. So this is a cell, the inside of a cell in a super microscope. Okay? This is actually the cell separation. One of the things here that is pretty important is this is part of our life sciences division. And we're doing a lot of IoT, real IoT, M2M and IoT here. The way this is basically cells, and what's happening here is we were monitoring the cell separation. The cell separation will define in a lot of cases if it's a cancer cell or it's not the cancer cell, even before it starts to say anything. So by doing this, there are a bunch of metrics which this equipment, which is a super microscope, is getting. All this tracking data is being fed, is being shared within several different research organizations worldwide, which allow to identify, okay, patterns within here, which allow to identify this here is actually the detailed version of this, because each of those elements, so each of those points here, this is, I can tell you, this is a cancer cell because of the number of points, because you normally don't have that many points. So even before it started to have a problem, we're getting this. Why? Because we're leveraging IoT. Because we're getting this information in partnership with research labs worldwide. We're putting this information, feeding, and everybody joining this as the marketplace, and then crunching the data and coming up with new ideas. For example, there's a child in the US which has been getting some treatments, new treatments, and has been one of the people involved in this specific thing. This is IoT. Why? Doesn't have a boundary. It's worldwide. It's accessible. So we feed the information, we have the equipment, we feed the information, and then someone is processing research labs, pharmaceutical companies, and all of that. Does that help understanding a little bit the difference between M2M and IoT? Yeah? Okay. And also it has some cool features. So let's start with our outline. So what are we going to do? First, we're going to do an overview. What is actually this industry going right now? What's this industry like? Is this an actual business model? Because a lot of cases, and we hear about IoT every single day, like we used to hear big data every single day. We still have, but now it's more about IoT than big data. What is this really all about? What's the perspective? And then let's demystify it. I tried to start with demystifying this and getting the difference between what's M2M, what's Internet of Things. But let's dig deeper and understand what type of things we can see, and then how can we apply in some scenarios. So if you look at the overview, one of the things is, what is Internet of Things for you? What are the things that you hear every day about the Internet of Things?
Light bulbs.
What?
Light bulbs.
Light bulbs, the smart ones. Oh, really? Please run out of the building. So light bulbs, smart light bulbs. It's one of the parts. We're talking here about, we're talking here about things like it's the smart bulbs, it's energy, home automation, all those things. It's the wearables. Everybody now has a wearable. Everybody now has something which is the Fitbits or something like that in order to track how they are exercising and things like that. So those are Internet of Things. Those are sensors. Sensors and gateways. So sensor is one small element which sends information about a specific area. So for example, temperature sensor, light sensor, gyroscope, one of those. It's a sensor. Then you have a gateway, which is where the sensor actually connects to in order to be able to feed this information. That's where we are talking about Arduino, NetDuino, the Intel Galileo. Those are gateways. Raspberry Pi, those are gateways. So it's the way that the sensor sends information and connects with the world, because the sensor by itself does nothing apart from here's this information. Then we need to feed this information, do some smart work. That's where the gateway is the one that normally connects to the cloud. Okay, so Internet of Things is, no, you don't want to go. Okay, about machine-to-machine communication, mobility is about manufacturing, wearables, automation. A lot of people say different things, depends which area they are. But the Internet of Things is actually around actually getting several machines to communicate in between themselves and going into going and creating a marketplace, creating a sharing, unbounded sharing of information. That's what IoT is. And some cases you go and talk about IoT. It's only when we're talking about millions and millions of devices. No, it's not. It can be, why is this thing moving? So it's about actually going, and you can have small number of devices, but if they are sharing without any specific boundary, it's IoT. It's a small part, but it's IoT. It's the same thing as saying big data is only when you have massive terabytes of data. No, it's not. It can be massive volumes of data. It can be massive variety of data. It can be massive velocity of data. It will depend. So in here is the exact same thing. So one of the things is Internet of Things in the expectations graph, it's in the hype of the expectations, as it would be expected, because everybody now talks about this. There was actually some jokes around this, that a new technology like this is just like teenage sex. Everybody talks about it. Everybody thinks they know about it, but actually nobody really knows how to do it. So it's precisely the same thing. Everybody says, I have IoT, I have an IoT solution. I know exactly what IoT is. But then when you dig under the covers, it's very few number that actually have something. And so one of the cool things, let me bring here one cool thing, is this. Anybody knows this website, thankful.net? Yep. So this is pretty cool. This is about Internet of Things, social, go social. And so everybody can go and register their own device. And if I actually get this, it would start. So all the dots is actually sensors. Now the damn thing doesn't want to move. All the dots are sensors. Every type of dot is a different type of sensor. So this is a sensor for flora and fauna. It's Betsy's accelerometer, female white shark. You want to track a white shark? Yeah, just do watch, and you're now tracking a white shark. Also, if I want to see flights, I want to see flights in London, please. Shouldn't be hard. So this is a B7552 transport flight. This is the altitude is going. Let's see this one. This is a, did I hit the same one all over again? This is another transport. And so you can actually see the several flights. In some cases, you can actually find some commercial flights somewhere. It will tell you exactly which flight it is. Also, you can see things like, I would expect this to be a boat. Okay, so this is yacht, Potvis. So this is Internet of Things Go Social. Okay, so they created a site which allow us to get all other people sensor, the one that are being shown and made available, and then we can go from there. So it's a pretty cool concept. What does this mean? It means that I now can actually hook it up into someone else's sensor, use that data in order to do something different, some application. This is IoT, this is a real deal. So getting back to our presentation, so we are in the hype of the expectation. So if we see big data like expected, everybody was last year, this is going to solve everything, every single problem in the world, everything. Now it's getting down because we're getting down to reality and saying, yeah, we actually sold big data as the best thing since the wheel. It's yet another option for us to deliver things. It's not just because I have a hammer, not everything is a nail. So, and we need to understand, so we started to understand, yeah, okay, it's not going to solve. Now this is where it's going to solve, but this also goes to here, see where cloud computing is. Everybody went cloud computing, like 3-4 years ago, everybody was like, hey, cloud computing, solving the world. I'll never think about the machine again. And now everybody's like, oh, cloud computing. It's just running your stuff somewhere else. We'll get there. We'll actually get to the full capability of it. But this is what happens when we don't manage expectations. So, but in terms of Internet of Things, is this a really big deal, and do we know how big it is? So apparently there are some people that say, oh, this is about 50 billion devices. And then the other goes, no. So Morgan Stanley says, no, it's 75 billion devices. And then someone comes and says, no, you're all wrong. This is actually about 212 billion. And then there is one saying that is $8.9 trillion in there. It's like, yeah, this is a perfect example of we have no clue about what the market is. Because if we had, we wouldn't go from 50, 75, yeah, okay, that one was not too bad, 212 billion. It's like, okay, now you went just nuts. And yeah, it might get there, but it just means, it doesn't mean they are wrong or any of the others are wrong. It just means that nobody's using the same ways in order to track that. So we have complete, it's an open market. We have no clue if this is going to, how many sensors, because for example, if we put sensors on the Tube of London, imagine the number of them. It's massive. And then it depends. If we say, I'm going to put in the Tube of London in every single part of the tube, from the trains to the parts, the rails and everything, then if we go there, then we'll destroy this number, right? If we do this everywhere. So it's a very big market. It's a worldwide Internet of Things. The revenue opportunity in 2014, they said it's $2.29 trillion. And they expect that by 2018 to be about $4.59 trillion. Some think that it's $8.2 trillion. It's a lot of money. So it's worth taking a look at it. Okay. But the thing we know is it's big. It's noisy. Everybody has its own definition. Gartner definition, IDC, Forrester, none of them have the same definition about what's Internet of Things. Where have we seen this before? Anybody?
Internet, maybe?
Internet, big data, cloud computing, pretty much every hype word we have ever had. It's like everybody goes and says, I have one of those. I remember when I first started working in cloud computing, I had a friend of mine coming and saying, hey, I have now a cloud computing offering. Oh yeah, oh cool. So when can I start it? Can I register online? Oh no, you need to call me. It's like, okay. So how do I provision something? You call me or you email this form and in 3 weeks I'll get you that. And it's like, I'm pretty sure that's not cloud. How do I pay? Oh, you need to rent it for at least 1 year. It's like, really? You didn't figure out what the cloud was, right? And that keeps happening over and over. That's something we have, is the power of saying, yeah, we have that. I understand all of that. And basically, not all understand really. So this makes it very confusing. Very confusing to customers, very confusing to everybody. And from a historical computer, what was the world's first computer? Who knows? You have only 2 operations you could do in that computer. And even your parents, independently how old they were, use it. No, even before. Yeah, abacus was a good one. So, a pencil is the first computer. Had 2 operations. One is print. It prints something, and it deletes something. But we now are not only in that. So we now expect, I'm going to medical practice, and I would love to have this, by the way. Because, for example, when my wife was pregnant, I remember going like at 4:30 p.m. to the doctor and having, because the consultation was about 4:45, and I have the consultation, we had the consultation at about 10:30 p.m. So really cool. So I'd love to actually say, okay, send me a notification. I have some other things to do apart from sitting down in a doctor's office waiting. So we now are here. We now want everything to come to us. Instead of us going and wasting our time, we want everything quicker, better, and exactly contextualized to what I need. So, and that's the reason why we are having this. So we go to medical practice and say, oh, the doctor isn't in, but can we do a Skype thing? That would be lovely. We're actually already testing some of those. Then there are all kinds of things. So for example, there was a study that, you know that in terms of memory, right now, there's a study saying that the way we memorize things now is completely different from before. Did you know that? For example, how many of you now can't remember exactly what something is, for example, a technology is, but remember exactly which search words you used in order to search for it? Now we have our brains is starting to get a indexing mechanism instead of storing. We just store the pointers to something. And this is where we are going. And so it has challenges. We have more social, more economics, more technological. We have the Moore's Law, which is very interesting, and also innovation. This is where we see threats and opportunities. And then in order to go to something like IoT, you need to see a threat as an opportunity for you to do better. If you don't, because it's an unknown world. Yeah, there's a lot of people talking about it, but from talking to actually when you go to a customer and say, here's a solution, here's how much it's going to cost, it's going to take a little bit of time in order for people to start picking that up. So challenges around developers. Developers need to think about the different thing. So for example, I love to do some crazy pet projects. One of them was a beer bot. With a Lego Mindstorm. How many of you have the Lego Mindstorm, the Eve 3? It's pretty cool. So I decided to have all the different dragons, snakes, and all the things. I decided that I really need a beer bot. And doing a beer bot, so I started plugged in a little bit of a Raspberry Pi into it, a couple of sensors in order to feed into the cloud, the location and everything, and I gave it some artificial intelligence in order to know, okay, if you go against the wall, it's an unmovable object, defining what's an unmovable and movable, and then be able to see if it stands there and waits or if it goes and works around. It's pretty cool. In terms of the way you develop something like this, is nowhere even close to the way we develop applications. The scale is not even close to what we are used to. So, for example, one of the common mistakes in IoT is when, I have, for example, a tablet. Tablet receives over-the-air updates and receives all those things. So one of the things, I have a massive ingestion. Imagine now going have, again, the Tube of London is starting, has all the sensors and is feeding. What do? We put services, right? We're in a services world. so oriented. So we put services which they connect to, right? Right or no? Is that the right pattern? Yes or no?
Depends what you do.
Depends on what you're doing. In an Internet of Things is the wrong pattern. Data ingestion is massive. If you put a service, you basically the only thing you're doing is choking the system, because you'll need to have massive number of endpoints. You need to scale massively. So as an example, we tried doing the first one with web APIs where the devices, the sensors would throw into web APIs and we scale. We have about 1 million sensors across, where we're basically sending around between 5 to 10 million messages a second, status a second. And we have this as a service-oriented architecture. We have web APIs twisted. They were into the last nut and bolt. Tweaked. The cost of that thing apparently was not very interesting. It cost us about $2 million in the cloud to have to host that thing. $2 million. Okay? So we said, $2 million is a little bit too much. So let's try to do something. And also there was a problem. Every now and then we were losing status, and we didn't want that. And if you, for example, think about PlayStation or Xbox and things, they are feeding status information every single second, even on a game. How many of you play things like Halo or Titanfalls or test those things? I don't play it, I just test them every now and then. So those are in real time sending information. For example, Halo changes the scenery based on how you're playing. In my previous life before GE, I worked with a team. And the way you actually are playing, if you're basically going after and just hiding under a rock, newsflash, the rock won't be there, because we'll change it in real time. So it's different. And so what did we do? We actually, even for the Xbox, we went to a different pattern. We said, we can't lose anything. We need to have scale. What is something that gives you reliability, availability, and scalability? RAS. Udi Dahan is not here, but you would love this one. Reliability, availability, and scalability. Yeah, that's one thing, but it's actually queuing. Queuing gives you that. So if you go things like Kafka, like ZeroMQ, or if you want to do less heavy lifting, you go to something like Rabbit or ActiveMQ, something like that. That's the right way, that's the right pattern when you're talking about Internet of Things. Why? It's reliable. It's reliable, you don't lose anything. It gives you the endpoint, but it's highly optimized already. And it's scalable. I can scale the services. So the difference was we were using Azure, and before we were using APIs on websites, and we tried also with web roles, and it was about 1 million. Then we did, and we said, okay, hold on. They came up with event hubs. Let me use event hubs. I used event hubs. It cost me, just for doing that change and going for a microservices pattern, it just meant that for the exact same amount of things, I started paying about 100,000 a year, from 2 million to 100,000. So that's a pretty good pattern. So if you're doing IoT, yeah, you can play around with your own things. In order to play around with my beer bot, I'm still using APIs. As soon as you scale this, forget APIs. They won't allow you to do that. At least in a normal way, in order for you to actually make money, which is at the end of the day what we're trying to do, right? So that's an important challenge. It's a different mindset, different development tools. You need to think differently. How many of you have thought about microservices and know what microservices pattern is? Okay, so good connection to my next session after lunch. So microservice is basically a way, an architecture, a design pattern where you actually break it down, break the services down into very small elements. They normally they are independent of each other. They communicate through messaging in order to make things simpler. So if you think about what the microservices is, the concept is like in assembly line, you get very specific focus robot or person doing that thing. The only thing, they don't care about what happens before or after. They care about, I receive this type of message, I do my work, and I put back in the bus. Same thing as in an assembly line. I think something out, I do something, I put something in. Next one. So it's a different pattern. Line of business and device. It's also very hard for business people to figure out what the business model is. And knowledge workers, data scientists, they love this, but it's a challenge. Because suddenly they need to look at millions and millions and millions of status. So, and one of the challenges in the status is, for example, millions of senders. This was something from one game. This was in Halo 4, we would have spikes in terms of usage. What this means is, so if you see this is 6 a.m., 12, and it's very ramping up very quickly. So it's around 6 a.m. it will ramp up. That's pretty interesting because that was about 10 p.m. in West Coast, so it's where the gamers will start going crazy. And it was not a smooth going up. It just bam. So yes, it was kindly of a predictable element, but it's very hard to scale that because the scale of this was like something like 100 instances here to about 5,000 here. It's yeah, if you miss it, it's pretty bad. So with messaging, this became a lot better. So this is a little bit of an overview. Did this help? Good overview? Okay. Now demystifying. What is really Internet of Things? So it's about things. It's about what we call, some people call as the cool kids. If you are one of the cool kids, you don't talk about Internet of Things. You talk about connected devices because it sounds like you actually know what the hell you're talking about. Because it's actually things, connected things. It's something that is connected. Oh, no, it needs to be a sensor. No, it's a thing. It's anything that is connected. Then, so it's things, it's connectivity, it's data. So we basically have things that are connected, that generates data. That thing is sending data that we analyze. That's why Internet of Things, or the connected devices, is all about. It's about how do I leverage the data that those things are getting. For example, if I want to do weather forecasting, how do I leverage the weather information that comes from millions of sensors and I analyze this quicker? For example, if I'm in financial services in insurance company, how am I going to leverage weather information, police information, accident information, service history information from cars in order to, when I'm going to sell an insurance, I actually know the risk. And this actually exists. There is a database have all the history of accidents, and then there is already, so how many of you know the Teslas? I love the Teslas. The only thing I hate is the price. Apart from that, I love the Tesla S supercharger. I'll get one, but damn, 100,000, it's a little bit too much. But it's amazing car, electrical car, full of sensors. You don't need to go to a service. It actually updates the damn thing. You have over-the-air updates for the car. You have actually the sensors are sending the information. You can go online and see your speed, which is really nice because you can understand where you were and what speed you did. So if you get a speeding ticket, you actually know, yeah, it was someone actually in the US tried to use that in court. But then someone else, all the other people started to say, please, 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 don't open that door, because then the other way is also possible, and that might not be as cool. But that's the power, and those are the choices that we need to do. Things that connect to send data to get analyzed. That's Internet of Things. Unboundary. If it's with a boundary, within the hospital, within a car brand, within something, then we're talking about machine-to-machine communication. So, it's about hyperscale, millions of customers, concurrent. So I have like 10,000 or a million customers. I don't know. Basically, when we create an Internet of Things, we have no clue how many people are going to use it. So we need to think about that. Also known as systems of systems. And things, for example, imagine that I have home energy. Anybody has smart home automation things like Nests and things like that? It's pretty cool. You can control the temperature of your house based on that. They now have a couple of other sensors which control electricity and control a bunch of other crazy things. It's pretty cool. Smart grids, hospital automations, responsive store, all of those things, they are basically feeding information. So it's systems of systems, massive numbers of sensors and systems interconnecting and reusing. So for example, in home automation, the home energy, I might be getting feeds from the smart grid in order to understand if there is a spike. And in the smart grid, I can actually see, oh, there's a concert today in that area, or there is a game. Actually, in Portugal, we have some cases we have this. So, for example, they built a new pool. It was a wave pool. It was a great idea in a small city. It was a massive idea. The problem was nobody remembered that when you plug in, you actually turn on in order to do the waves. Actually, the city went down. So no problem there. So I want waves, okay? So hold on, you don't need energy now because we're consuming all the energy and we have priority because we want to surf the waves. Makes sense. So in smart grids, what we can do right now is when we have information about concerts, about those kind of things coming from sensors and other systems, we can actually apply. The smart grid can basically send more energy to one side than the other. So we can actually, in real time, feed this information. Wearables. So the Fitbits, the smart trainers, pretty cool. They track what you're doing. So you have this that actually tracks your weight and continues to process things. The Google Glass and already now the HoloLens. Have you tried the HoloLens? It's really incredible. Really incredible. You even have smart bras. So we are there. Industrial automation, things like in real time, and this is machine-to-machine communication. Why? It's confined right now in this factory. If I start connecting with all of my factories, then it will get to Internet of Things. So in this case, I can actually know, and imagine this is a delivery company. I can actually, since the element goes in, I can track immediately where it is, how it is, what type of system, how create SLAs on those systems, track all of those. This is the power. Energy and smart grids, gaming. This is where it's being used massively. It's one of the places where IoT patterns are used massively. It's in the games. Game space, getting all this data. So when you're playing, for example, there is the Connect Sport Rivals. When you're playing, actually you're getting all the information. The score is not done in the machine itself. The score is done online. And it's done basically by looking at every other person that is playing out there in the world and creating the score. So everybody gets the status, and by the way, there is other status going, like the status of the machine itself in order to get. And then that is being used for other things like understanding what's the type of usage, what's the type of predictability. And then we can, the holy grail why everybody is going into the Internet of Things is when we have massive loads of data, what's the opportunity there? Sell it. So if I have massive amounts of data around how, around, for example, the cars, have all the car information, all the information that comes from a sensor in a car. And a car has, a normal car should have right now about 100 ECUs, electronic computing units. So sensors, the sensor that actually is defining how many fuel is it going to use and things like that. Imagine that you hold all that data and you are able to share that data. The holy grail, while everybody is trying to go there, is whoever has the data controls everything. If I can share the data, sell that data, now I control most of the things. I can understand the patterns of usage, I can build better products, I can adjust. That's the reason why everybody keeps saying they are doing this. Does that make sense? Okay, so the thing, specialized autonomous piece of hardware capable of performing simple focused tasks. Again, thing, very focused. Data, isolated elements that send and receive things. This is normally the gateway. Connectivity, in order to be able to connect, and management. We need to understand how are we going to manage this. Because this is a little bit like the bring your own device in companies. Bring your own device in companies, great idea. It just created a massive security hell for everybody. Because now security teams are trying to enforce policies and so on. One of the things, there is a new acronym that is, there is IoT and IOST. Anybody has an idea why the S? Internet of Secure Things. Because we need to have security. Because it's pretty cool. Oh, I have a home automation. It's connecting to the web, and I can control my heating, and I have my webcams at home in order for security systems. It's all really cool and great, but it's not secure. Oh crap. Someone else can be looking what I have at home. Oh crap. So we need security. And sometimes we jump too quickly before we actually figure out if you have a parachute or not. So and that happens. Fortunately, I didn't try that stuff. Internet of Things. So IoT service, home automation, health services, energy service. This is an Internet of Things service. It's not a thing, it's a service, it's a solution that we build. A gateway, examples of gateway, Raspberry Pi, Arduino, Nest, router, smartphone, that's a gateway. This is a gateway for a lot of sensors that we have here. Even one that tracks how many steps I do, which every now and then I get happy and sometimes I get depressed when I see it. Then the nodes, or the sensors. From big appliances, we have the smart fridge. Anybody has a smart fridge? It's pretty cool. I haven't bought one, but I've been going on the process trying to convince to spend that much amount of money for a fridge, which is weird for a guy to be thinking about the fridge. But the fridge is cool. You actually put things, he actually analyzes what you have inside the fridge and your normal usage of those elements. And you can actually connect and say, this is the shops that I normally ordered from. And so when he sees that, oh, you're going to run out of yogurt or beer or something, he basically puts an order immediately. It's so cool. Come on, it's cool. I'm trying to convince my wife to get one of those. So it's for some reason it's my beer fridge, which would be cool. So home security, environment sensors, all those kind of sensors. So we have, what do we do with it? Examples, smart grids, health service. So for example, and this is right now an M2M is getting to Internet of Things in the next step, is imagine you're a doctor inside a hospital. Every now and then there is some protocols that are ignored for some reason, and there are lawsuits. One of the things is, imagine that you have a badge. I'm a doctor, I have a badge. I go within the hospital and I'm being tracked. I know exactly where I am, instead of, please, Dr. Marshall, come to the reception. I know exactly where the people are. I know exactly if they go to the OR. I know exactly if they actually pass through the right elements, because I have sensors like in every single step in order to see, and then cameras in order to see if the right cleanup was made, if the right steps were made. When you're entering information, if you're actually getting surgery through the right arm, for example. Because I remember one of that stunt, I had a problem in my right knee, and I went, and the doctor starts grabbing my left knee and shaking it, and I'm like, why are you doing that? Oh, I'm trying to see what's the problem. It didn't have a problem, but if you continue shaking it like that, I'm pretty sure it will. So, oh, wasn't it the left leg? No, it's the right. It's the one that actually has the surgery mark. I don't know. It might be easier to look at the surgery marks. So sometimes that happens, so trying to get that information. So imagine that. In terms of taxonomy, we have, when we talk about devices, we have a taxonomy in order to make it simpler. We have the large, so the big, this one, I needed to put something from GE. This is a GE MRI. So the big things, the middle things like your point of sales and things like that, that can be your device also. Embedded technologies. So one of the things, there are cars, Tesla is one of them, Jaguar is working, Ford is working, BMW is working on smart technologies, infotainments, where you actually get upgrades for the firmware of your car over the air, like it was a tablet. Some of them you need to be stopped. It would be interesting. No, it's not a Windows device. You don't need to restart when you finish the update, fortunately. That's the reason why you need to be stopped in order to do some of them. And the micro ones, the smaller things. So taxonomy, you have large, mobile, small, and micro. Okay, how does it work? How do we connect all those small sensors? Like this, right? It's just cabling. It's just a cabling issue. No, with Wi-Fi, we're doing a lot of process. So the basic way is we always go through a first step. So I have a sensor. The sensor identifies himself. Security. Security by design. So you need to have security, 3 things. Security by design. So when I design, when I start to draw something, I need to think security. Security by default, for example, this thing or a Windows phone or something, you only can install some things from other devices when you jailbreak it. So you have by default security is embedded. And then you have security by deploy. So the way you deploy also is security. One of the things is we need to identify. So we thought it through. We need to identify on the design phase, how do we identify this system? What's the way I'm going to identify? Then I'm going to do the security by default and say, okay, by default, I'm actually going to restrict the MAC addresses because I know the MAC address of that. So I'm putting by default, and I'm putting that by default, you can't install anything else on that wearable or in that sensor. And then I'm going by deploy. I'm going to deploy this on a cloud which is secure with firewalls and things like that. 3 steps. So identity, then you have the edge node. So this sensor doesn't connect directly. It needs to go through the gateway in order to connect. It identifies to the cloud, but it needs to go through the gateway. Then you have the service, which is what you're trying to achieve. And then fourth, you have the end user, which is doing things. This is, if you're thinking about today, if you decide to do a beer bot or any other crazy bot, and start to play around with the Internet of Things, 2 things will happen. One is you love it. Why? Because you're going to enter a completely new way of developing. And that is not only going, and one of the common mistakes is, oh, I'm not doing Internet of Things. I don't have massive numbers of sensors, so this doesn't help me. Actually, it does a lot in your current day-to-day. For example, one of the things, after starting to do this kind of play and understanding I can't use the APIs directly, I need to use buses, I need to use microservices. Imagine what happens when I now do any other type of application, even if it's not IoT. I know exactly the patterns that make things go reliable, available, scalable, more cost effective. I know the patterns that can create decoupling. I know the patterns that allow me to do massive data ingestion and massive data analysis. Is this a benefit to any other type of applications? It is. Massive. So for example, for logging, how many of you do logging in the applications? Right? We all have the logging, hopefully. So that's pretty cool. Logging is about, how many of you actually look at the logs that thing is generating? Yeah, if you're unlucky and something blew up, you go open the log and it's like, Or I remember a friend of mine worked in a telco company that they had the live logging, which was basically the black screen with a lot of white lines going in a very big speed. And every now and then they change to either yellow or red. If it's a red, she would go and start trying to figure out. It was a very, very interesting job, by the way. So what happens now is, imagine that I know now how Internet of Things work. How devices, sensors send massive amounts of information in near real time, and I can act based on it and still make it affordable. Perfect. And now you're starting, if you listen carefully, you're starting to go from logging in applications to telemetry in applications, which is a more Formula One related type of things. Real-time understanding how each of the parts of your application is behaving. Because, for example, imagine I'm doing something with cloud, with Azure, and I receive a package. I need to validate the package. I need to then store it in blob storage and do some storing also in SQL and so on. If I do logging, I can only understand if I'm having a brownout or having some issues after the fact, because I need to go through the logs. And the logs is not about what will happen, is about what's happening after the fact. And I then need to, I have here a log of a failure connecting, another log of a failure, and in between there's like 100,000 lines. And then I need to create some log parsing mechanism. Now imagine that you do an opposite thing. You actually say, forget the logging, I'm going to say that logging is only about sending a status information. Logging, what's logging? It's just taking a status and sending. Let's put that into a message bus and put all the status changes. And then since a message bus, I can actually use complex event processing and see patterns and say, in like 10 seconds or whatever, this time sliding window, if like 10 of those happen in this time window, I want you to fall back to the secondary store, to the secondary location, to the secondary storage account, and things like that. With that, you'll know exactly in real time how are each of the parts of the application behaving, and you can actually act on it. So, for example, this is why the cloud, AWS, Microsoft, is able to do what they do. They are using this type of IoT patterns where every single node is a sensor, is feeding the information, telemetry information, status information into a message hub. And then there is one node, head node, which is called the fabric controller, which is actually looking at that and saying, oh, I have a couple of failures from that machine, kill the machine and change everything that is in that machine somewhere else. Nobody looked at the logs. That's why they have a ratio of 1 person per about 100,000 machines in terms of support. Right? That's why the economy is scale. This is also something you can extrapolate into your own apps and start thinking that. So, building IoT solution, we need devices, we need services, intelligence devices, connect to something in order to gain. And the real power is not only about having devices and data, it's about what you do with it. You need to do something with it. You need to master it, you need to visualize it. The same as big data. I can process the data if I don't visualize it right. If I don't give the right data at the right time to the right person, doesn't matter. It can be the best, the most awesome big data solution in the world, IoT solution in the world. If it doesn't give the right data at the right time at the right person, doesn't matter. So, class of events, you have standard, mobile, compact, and micro. Microsoft has a bunch of those. So with Windows 10, they're actually putting the same in pretty much every single device, which is interesting because now Intel is putting in their system on a chip and things like that. And then you can actually create the industrial devices. And the way we use it, it's basically we have things, we take the data, create the store, perform some insights. How many of you have played around with Spark? Hadoop? Spark? No? Should take a look at it. It's pretty cool. It's about 100 times faster because it does in-memory map reduce. So it's 100 times faster there. If you do even normal, it's about 10 times faster. It's a different way of working. And this will allow you to create. So this is how you can use, and the most important part, command and control. So we have things, we have the sensors. The sensors are sending information. The information is stored. We're then generating insights based on that and connecting with other things like predictive maintenance and some of those things. And then controlling and saying, hey, sensor, do this instead. An example of this. So I asked if you knew if this was changing our lives every day. We're in London, so I thought this would be a...
Carrying more than 1 billion passengers every year, the iconic London Underground is the world's first underground railway. I'm Steve Pears, Managing Director at Talent Technology. We wanted to help rail organisations like London Underground modernise the systems that monitor its critical assets. Everything from escalators and lifts and HVAC control systems to CCTV and communication networks. We teamed up with CGI and Microsoft. This collaboration includes taking advantage of the Microsoft Azure Intelligent Systems Service. Meaningful data from sensors and intelligent edge devices on everything from temperature, vibration and humidity to fault warnings and system alerts are available securely in the cloud. Many manual monitoring processes can now be streamlined. Disconnected systems can be securely integrated and automated. Most importantly, equipment degradation can be spotted in real time based on live data. And with new insights from data, London Underground can measure asset performance over time. When one system can connect thousands of devices and data streams across a rail network serving millions of people, that's the Internet of Things, and it's here right now. That's why we chose Microsoft.
So this is actually something that affects us all today. So the London Tube is already being tracked with sensors, vibration sensors. The way they actually know what time is the train going to arrive, it's because of the sensors. So every now and then we start now to get preventive maintenance, because they actually, before the thing breaks, they actually go there. And most of all, they can actually say, okay, this one broke, we didn't find the pattern. Now let me understand what happened just before it breaks. And now I can extrapolate and say, oh, hold on, I have the same part somewhere else which has the same type of pattern happening. So I immediately get to the second system, control the second system and say, hey, you should go and send someone to replace that part because that is going to break. Right? This is happening now. So the Internet of Things, there is a lot of hype. There is a lot of, everybody knows what the Internet of Things is and everybody has a little bit, but it's real. It's real, it has money. How much? Nobody really knows. Opportunities? Definitely. What exactly are the opportunities? Nobody actually knows for sure. Everybody's trying to figure that out. Is it already helping us? Yes. This is an example. Tyson elevators, Tyson Crips is another one. They are actually already tracking with sensors the information and seeing where things are. Smart cars are real. We are already, so Tesla has a bunch of them. There are new cars coming up. The self-driving cars, it's based on sensors, it's based on IoT. The only reason why they are able to exist is because of this. And it's reachable to anybody, because also the marketplace is a critical part. So we create this marketplace, but it's accessible to anybody. So the same way there was person, you know how EMDB started, right? A person with a passion for movies that decided to put his own collection, his own information, and sell it online. And suddenly, everybody now, if you're not on the IMDb and you don't have a rating, it's like the movie didn't even exist. Same opportunity is, and it's reachable. The Pi, Raspberry Pi, is basically something which is very capable. It's an amazing board, amazing gateway. It's about $40. Each sensor will be like $10, $20. It's very easy, very cheap. Another one, NetDuino, if you're more in a .NET kind of things, this is about $50. This Intel Sharp Cove or the new one, which is the, I can't remember the name, Edison. It's about $50 to $60, roughly. So we are also the Galileo from Intel, also $50. And the size of the thing is actually 5 millimeters. So you can put it anywhere. So every now and then, but yeah, I'm a little bit crazy sometimes. I buy one of these and I put it in just like in a remote car. Just plug it in. I normally use, so this Galileo board, it's my preferred one right now. I don't have an Edison yet. So I put it in and start going around with the car and checking the information. Then I go and put sensors in it. Then I basically start controlling it even when I'm not in the house and freaking the hell out of everybody. It's just cool. I'm just building now my telepresence robot because it's cool. He goes over in the office, scares the hell out of everybody. It's just fun. And that's command and control. I'm someone else. I don't have a boundary. I have a device which is feeding information about where it is, and I'm controlling remotely from that device. I have an IoT pattern. So, in terms of applicability, things like digital signatures and things understanding. For example, when you go to one of the ad boards outside, there are some of the electronic ads already, right? You have the electronics that shift between ads and everything. One of the cool things in those ad boards is that most of them there was a new technology. It's pretty cool. They can make every single pixel a camera. So we will know exactly where are you looking at, the heat map of that thing. So that means that if I have two ads in the same board, I know exactly where people is looking. I can do an A/B testing immediately. And also I can, because we are a business, I can charge more for the place where people normally look at, like in supermarkets and things like that, where you pay for what's on your eyesight more than everything else. This is here now. So they are connecting actually this to the internet, and they are getting feedback from everything else and saying this is the ad that people most time spend looking at it. So they actually start changing all the other ads, basically electronic ads, in order to make that is the one that is getting. In some cases, the teams actually come up and say, here are a couple of ads. They rotate the ads. Then they figure out which ad is the one that is getting more attention from. And then they start using that one. So they do immediately testing. That's one of the applications. So some other application, digital sign, Raspberry Pi, it's very small. View data errors, that's one of the first over-the-air update. And things like client-side app, the challenges, problems. Client-side app, cost to learn. Yes, it's a different pattern. It's a different way of looking at things. There's a burden there. It's not a problem. It's an opportunity. It's an opportunity for us to get better in development. Alerts and rules. Line of business applications. You need to understand most of the product owners today, when you ask, okay, now I have all this real-time metrics, which ones are the ones that should generate an alert? They will need to think outside the box. A lot of them are not ready for that, so it's an adjustment. Maintenance, secure over-the-air updates. How do I do versioning? It's very hard, very hard. If you use microservices pattern, it makes your life easier. Security, how do I authenticate? Messaging bus, what's the costs? Which type? There are like thousands of buses. So ActiveMQ, RabbitMQ, ZeroMQ, Kafka, Event Hubs, Service Bus, queues, topics. There's a bunch of them. It's like, how the heck do I choose from them? We need to choose the right tool for the right job. It's not one size fits all. Right tool, right job. Analytics. How do I build graphs? More important right now. So in one of the things that is being used a lot is a new inference model, graph model, where we can infer things from. So it's a XML-based document, which then you can infer. So for example, I can say, this is my car. My car has a bunch of sensors, a bunch of information. But then a car belongs to a manufacturer. A manufacturer belongs to a bunch of things. But they are not tightly coupled. It's just by inference. By some of the properties, I can infer that something else. The relationship in between things. That's how graphs operate. Device onboarding. One of the issues is, when a new device comes, how do I onboard? How do I make it secure? Do I allow everybody to onboard the new device? Do I need to control? Do I allow any type of device, or do I align only for a controlled type of device? Like for example, in my company, I'm not able for now to use a Windows phone. I can use either Android or this one. Why? Because it's what actually they have as a corporate policy. Might not agree, but it's a corporate policy. We had to, in order to provide security, they had to start somewhere. And sometimes we actually said, okay, for now, this is the sensors we want. There are a bunch of other sensors, but let's start with a couple, and then we'll grow. Costs. And so what's the cost? How much is the SLA? And also, it's very often that I get people asking, like, I want a 5.9 SLA. It's possible. It depends how deep your pockets are. And do you really need a 5.9 SLA? Can you have service degradation? For example, I'm doing weather information. I have sensors for weather. If I miss a couple of data points, is that the end of the world? No, probably it's not. Probably it's not. If I miss like 5-10 minutes, probably it's not. So my SLA should work accordingly. The problem is, most of the times when you go there, we want, there was one customer when I was in services that actually came and said, no, not even 5.9s. I want 100% of availability. Apart from that fact not existing, because there was always downtime, it's, He actually was good for me to have a page saying we are in maintenance during a period of time. So it's like, oh, that's easy. That's easy. That's also a way for you to mitigate the SLAs. So we saw the talent case study. Tyson Groups is also online. You can take a look. So it's real. And this is always about the right strategy. Start by connecting your devices. Start by playing around in a controlled environment, in machine-to-machine communication. Try to understand what type of sensor data is he sending. What type of ways of protocols is it using? All of those things. Then you basically go and say, oh, let me join now a service in the cloud. You start local, doing some crazy things. Then you say, oh, let me try sending this to another service in the cloud. Then you combine data from another data point. So if I'm doing my beer bot, I'm getting information, GPS information about my car, my house. Suddenly I start to go and also getting information from another service which was providing me georeferencing and helping get artificial intelligence, because I really didn't want to implement that. So I was sending information and he was sending me what I would need to do. So first combination. Then I start generating the insights out of it and making decisions into the device and say turn right, turn left, wait for something. My bot didn't have, by the way, a very happy life. The first or second time, the strategy of the bot was I would go and say with my smartphone, go and pick up a beer. He would go, he would know his way around to get to the kitchen. But I didn't have an arm Wasn't able to get the arm. So I invented a new strategy. It would start spinning and beeping until someone actually put a beer on top of the bot. Apparently that didn't work because for some reason my wife kicked it. Didn't enjoy. But it's cool. I decided that my bot had some glitches. One of them is being breakable and done by Legos, which is also a good thing because I can rebuild it. So it's pretty cool. So it's the right strategy. There is no wrong path here. The only right path is you need to try it out. It's cheap. You can do it spare time and everything. That's how I did it. And after that, I become much better, even doing other types of applications. And also, you open a whole new door for a bunch of things that are happening, and it will, in the future, be very valuable for you. So that's the power of Internet of Things. Questions?
Is there a place you got started with this beer bot? Did you look at videos? Did you just grab a...
So in order to do this, I basically started with I got the Eve 3 from Lego. I started building and playing around with it and doing, okay, this is what the book says. And then I started, okay, I need to put here a couple of sensors. So I went online and I searched for how can I put, in that case it was a Raspberry Pi connected, replace actually the controller, the computer of that with a Raspberry Pi. And so I figured out, and I actually didn't want to completely replace because there were some actions that I wanted and I didn't want to control the wheels, for example. Just want to upgrade some things. So I actually found out the way that you can actually put the Raspberry Pi there and actually connect. So I basically destroyed the thing. I ripped it apart and I connected, and now it's connecting to the other one. So it feeds to the main that comes with Eve and actually feeds the same data into the Raspberry Pi. Then what I started to do is just, okay, let me buy a crazy sensor and say, what's coming? And based on the data, I started looking online and saying, okay, if I have my georeferenced data, how do I identify with the camera? How do I identify if something is movable or immovable based on the camera? And so there were a couple of things, algorithms, and languages that I had no clue it even existed. And it's like, oh, cool. Let me get this code and start playing around. And it's a complete R&D. It depends on you. There are some good elements. So if you want to do a robot with IoT, there are some good robots there. If you go to there was Kickstarters, there was a couple of projects. There is, even in Eve 3, if you search Eve 3 and sensors, you'll see a lot of Arduinos and things like that. They have actually step-by-step guides, how to build your own thing. Even if you want to start, for example, with a car, with a remote-controlled car, they actually have, there was one that actually, it's a telepresence one, and that's the one I'm following now, is I have a remote car, so they do step by step. So open the remote, replace that thing with, in this case, is an Intel board, then what you do in the car, what you put it in, iPad in there, and so it has step by step. There is a lot of things out there. It's really cool. Questions? Was this helpful? Are you all going to start doing crazy IoT things? And I'll be afraid whenever I go into the street? Yes? No? Okay, thank you very much. Hope you get a great rest of the event.